In this video, we present our work, PartManip, Learning Cross-Category Generalizable Part Manipulation Policy from Point Cloud Observations. We build a realistic benchmark, including 494 different object instances from 11 different categories, borrowed from PartManip. We select objects that contain articulated doors or drawers with handles and objects that have buttons. Based on our benchmark, we propose 6 different tasks: press button, grasp handle, open door, open the drawer, and close drawer. We first design a part-aware reward and use the reward to train a state-based policy. Then we use imitation learning to distill the knowledge to vision-based policy, which doesn't take any oracle input. We also test our policy in the real world. Here is our demo. Thanks. Part-based manipulation is very common for our daily objects. When having a target part, we humans can successfully manipulate certain types of parts across different objects in a similar way. For example, we grasp the handle and pull out for the opening task. For an embodied agent, it's also important to manipulate objects by part to achieve their target. That's why in this work, we study generalizable part-based manipulation policy learning. To tackle this generalizable policy learning problem, we have 2 differences from previous works. Previous works take oracle object states input, such as the part mask and handle mask in the point cloud, which is unavailable in the real world. Also, the current policies train in a single category, which is hard to generalize to unseen object categories. Thus, we build a realistic benchmark, including 494 different object instances from 11 different categories, borrowed from PartManip. We select objects that contain articulated doors or drawers with handles and objects that have buttons. Based on our benchmark, we propose 6 different tasks: press button, grasp handle, open door, open the drawer, and close drawer. For example, in the opening door task, we have 363 training doors for training, 63 unseen doors in seen categories, and 77 unseen doors in unseen categories for testing. During training, we can parallelly train on multiple different objects in our simulators. Then, we will introduce our method. We first design a part-aware reward and use the reward to train a state-based policy. Then we use imitation learning to distill the knowledge to vision-based policy, which doesn't take any oracle input. We design a dense reward for these tasks to train a human-like policy. The part-moving reward encourages the part to move to the target pose. The handle distance reward encourages the gripper to close to the handle. The rotation reward encourages the gripper to attach the handle by the correct pose. We use the part-aware reward to train our state-based policy. To track the part state, we use the part bounding box and handle bounding box as input concatenated with the robot arm joint angle as the robot state. We transfer the observations to canonical space to further improve the generalizability. Besides, the state-based policy is also used to collect demonstrations. For vision-based policy, given partial point clouds of objects, we use a sparse unit to extract the per-point feature. The per-point feature is concatenated to point clouds as new input dimensions. Then, a point net is used to get the global feature of objects. The global feature is concatenated by the robot state and input to the actor and critic MLP to predict the final actions. To train the whole pipeline, we first use collected demonstrations to pre-train the vision backbone and policy network. The policy is trained by behavior cloning. Then, we use Dagger to joint training the whole network. For each training step, we use the Dagger loss to update the vision policy. Furthermore, the domain classification branch is used for domain adversarial training, which is used to extract domain invariant features and improve the generalizability on unseen categories. This is the quantitative result of opening door. Our method outperforms other baselines by large margins, especially in unseen categories. The same goes for the opening drawer task. Our method still achieves state-of-the-art performance, especially in unseen categories. This qualitative results show our training results. Compared to previous works, our policy is part-aware and thus more similar to human behaviors. For example, our policy can use handles to open doors and drawers, as shown in our video. We also test our policy in the real world. Here is our demo. Thanks for watching. Please scan the QR code for more details and our code.